Welcome to Easy Tech Talk. In continuation of the previous video, we will talk about one layer of Snowflake architecture. In my previous video, I gave a brief introduction to Snowflake architecture. Now let's talk about the storage layer in this video. In traditional databases, data is stored row by row. So if you query just one column, the system still reads the entire row. That is inefficient for analytics. But Snowflake stores data in a columnar format, meaning each column is stored separately on disk. Whenever you load data using copy, snowpipe, insert, or merge, Snowflake automatically splits the table into small compressed chunks called micro-partitions, each around 50 to 500 MB. Inside every micro-partition, data is stored in a columnar format. That means Snowflake stores each column separately instead of row by row. Why is this a powerful concept? Because in analytics, we usually select only few columns like revenue, date, or customer ID, not all the columns from the table. With columnar storage, Snowflake reads only columns required for the query. That means less data scanned, better compression because you are storing similar data together. Faster aggregations like sum, count, average, lower compute cost. So instead of reading rows, Snowflake reads only what matters, that is column by column. That is a powerful columnar architecture in modern cloud data platforms. The next thing is that micro-partitions. What are micro-partitions? Snowflake automatically divides every table into small units called micro-partitions. Each micro-partition is around 50 to 500 MB, that is a compressed. These are created automatically, stored in cloud storage layer. You cannot manually create or manage them. Important thing is that Snowflake handles everything internally. No DBA tuning is required. So how Snowflake creates micro partitions? Whenever data is loaded into table using copy into snowpipe, insert, merge, merge. Snowflake takes incoming rows, groups them into chunks, compress them, store them as a micro partitions. Each micro partition contains actual data. Column level metadata is very important thing. I'll explain you. What is a column level metadata? Each micro partition stores metadata such as minimum value of each column, maximum value of each column, number of rows, and distinct values, null count, and um, other metadata details. Example, if micro partitions stores date from 2024 01 to 2024 0110, that is January 2024 uh, 1st to January 10th 2024. Snowflake knows minimum value is January 1st, maximum value is January 10th. So if I write a query, select star from orders where order date equal to 2025-0101. So Snowflake will skip this partition completely because uh, there is a partitions stored like a 2024-01 to 2024-010. So it will skip that partition because it only reads the required partitions. This is called partition pruning. What is partition pruning here? So partition pruning means Snowflake reads only relevant micro-partition. As I said, it skips the unnecessary partitions. It skips the unnecessary partitions. This improves the query speed, performance, cost efficiency. For example, if table has 1,000 micro-partitions and only 10 matches to your filter, so Snowflake scans only those 10 partitions. This is why Snowflake queries are very fast. So the next thing is this, how this is different from traditional partitioning. Traditional databases, it requires like DBA intervention, like DBA maintenance is required and manual partition key definition is required. But in Snowflake, it fully automatic partitioning. No manual tuning is required, no partition key is needed. Works for any column. This makes the architecture very simpler. Next thing is that Snowflake storage and security. Snowflake provides the built-in storage security automatically. We do not manually configure our complex encryption settings. First, all data is encrypted at rest. That means when data is stored in cloud storage, whether on AWS, S3 or Azure Blob or cloud storage, it encrypted using strong AES 256 encryption. Second, the data is encrypted in transit. That means whenever data moves from client to Snowflake, between compute to storage layer, or across regions, it is protected using TLS encryption. Third, Snowflake uses automatic key management. Encryption keys are like hierarchical managed, rotated regularly, protected using encryption keys. For higher compliance needs, Snowflake also support customer managed keys, so organization can control their own master encryption keys if required. The important things are security is automatic and always on. There is no way to disable encryption in Snowflake. So your interviewer may ask this question, can you disable this encryption? So you can say no. That's a part of Snowflake cloud native secure architecture. And the next thing is that Snowflake data protection. Snowflake protects data beyond just encryption. The first thing here we need to discuss is the time travel. The time travel allows us to access a historical version of data. If someone accidentally deletes or updates the data, we can restore it within the retention period. Second, fail-safe. So after time travel expires, Snowflake keeps data in a fail-safe for additional recovery purpose. This is mainly for the disaster recovery scenarios. The third important thing is that zero copy cloning. We can clone databases, schemas, tables instantly without copying physical data. This is useful for testing and development and backup environment. The fourth thing is that access control. Snowflake users are like role-based access control. We define roles, grant privileges to control who can view the data, modify data, drop objects, or some manage the objects. Uh, the next thing is that the network protection. The features like private connectivity, network policies, IP whistling, and additional layers. These are all comes under the network protection. So I can tell you like easy way to remember. The storage security means encryption. Data protection means recovery plus access control. Encryption protects data from hackers. Data protection protects data from the human mistakes. Thank you. If you have any questions or suggestions, please comment.